Hello, my dear students. Assalamu alaikum. Today we will discuss about artificial satellite. This is the lecture 4 for from gravitation. This is the lecture 4 from gravity and gravitation, chapter 6, physics, first paper. Now we will discuss about artificial satellite. This is the rocket. In rocket it has three layers. This is the one layer, second layer, first layer, second layer, third layer. So when the rocket moves upward, at a certain distance traveled by the rocket towards the horizontal to the earth's surface, the rocket this rocket moves towards the horizontal to the earth's surface, and this rocket moves parallel to the earth's surface. When the rocket moves at a certain distance travel, the rocket moves parallel to the earth's surface. At this point, the gravity downward and upthrust force upward. So both upthrust force and gravity both are equal. At this point, the rocket moves parallel to the earth's surface, then revolve to the earth, and the object revolved to the earth, and it is converted to artificial satellite. Again, when the rocket moves upward at a certain distance traveled by the rocket, at a certain point, upthrust force and gravity, when the upthrust force and gravity both are equal, at this point the rocket moves parallel to the earth's surface, and then the rocket revolves around the earth, and it is converted to artificial satellite. So now we will discuss about the velocity of artificial satellite, and the time period of artificial satellite, and the height of the artificial satellite. How we will calculate the velocity, height and time period of artificial satellite. This is the earth. Total mass of the earth is located at the center of the earth, and artificial satellite revolve around the earth at a certain height from the earth's surface is h. This height will be represented by small h, and this is the center of the earth. The radius of the earth will be r. So the distance between artificial satellite and the center of the earth is r plus h, and the mass of the artificial satellite is small m, and the velocity of artificial satellite is the direction of the velocity is tangent. So b is the velocity of artificial satellite, and the artificial satellite revolves around this path. So this is the path of artificial satellite. In this way, the artificial satellite revolves around the earth. When the artificial satellite moves around this path, the centripetal force is created. When the artificial satellite moves. The centripetal force Fc equal m. M is the mass of the satellite, and b is the velocity, mb square by r plus h. In which path the artificial satellite revolve. The radius of this path is r plus h. R will be the radius and h will be the height from the earth's surface. So mb square by r plus h. This is the centripetal force. This is the equation number 1, and this centripetal force is created from the gravitational attraction force between Earth and artificial satellite. So the gravitational attraction force Fg is G capital M small m divided by R plus H whole square. This is the gravitational attraction force between Earth and artificial satellite, cause the distance between center and artificial satellite is R plus H. M is the mass of the Earth, small m is the mass of the artificial satellite. So the gravitational attraction force is Fg equal G capital M small m divided by R plus H whole square. So this gravitational force for this gravitational force, the centrifugal force is created so that Fce and Fg both are equal. Fc and Fg both are equal. Now small mb square divided by R plus H equal G capital M small m divided by R plus H whole square. So small m cancel and one term R plus H from both sides is cancelled. So b square equal gm by R plus H. So b equal the velocity b equal root over gm divided by R plus H. So this is the formula of the velocity of artificial satellite. The formula of velocity of artificial satellite is b equal root over gm divided by R plus H. Now we calculate the velocity of artificial satellite by using this formula. Here g is the gravitational constant, m is the mass of the Earth, r is the radius of the Earth, and h is the height of artificial satellite from the Earth's surface. Now another formula of artificial satellite is the time required to complete one revolution of artificial satellite. The time required to complete one revolution by the artificial satellite, this time is called time period. So time period t in t time the distance traveled by the artificial satellite is equal to the circumference of the orbit. The circumference of the orbit is 2 pi R plus H. So this is the distance traveled by the artificial satellite, and this distance traveled by the time capital T is the time period. So the velocity b equal distance divided by time. So velocity equal b equal 2 pi R plus H divided by t. This is the another formula of velocity of artificial satellite. By using this formula we calculate the velocity of artificial satellite. Now we calculate the time period. The formula which formula we use to calculate the time period and the height of artificial satellite. We know that the velocity is b equal 2 pi R plus H divided by t. This is the formula of velocity. Another formula of velocity b equal root over g capital M divided by R plus H. So both equation represent the velocity of artificial satellite. So equating both equation 1 and equation 2, now equation 2 is equal to equation 1, equation 2 is equal to equation 1. So root over gm divided by R plus H is equal to pi R plus H divided by t. Now squaring both sides. So gm divided by R plus H equal 4 pi square R plus H whole square divided by t square. Now cross multiplication, t square gm divided by equal t square gm equal 4 pi square r plus h whole cube. Now t square equal 4 pi square r plus h whole cube divided by gm. Now square root from both sides, then we get t equal 2 pi root over r plus h whole cube divided by gm. So t equal 2 pi root over r plus h whole cube divided by gm. So this is the formula of time period. By using this formula we calculate the time period of artificial satellite. Now height of the artificial satellite is we know that again we start from velocity b equal 2 pi r plus h divided by t, and b equal root over gm divided by r plus h. So again start from this equation 1 and equation 2, both are equal. Now 2 pi r plus h divided by t equal root over gm divided by r plus h. Now squaring from both sides, so 4 pi square r plus h whole square equal gm divided by r plus h divided by t square. So cross multiplication from 4 pi square r plus h whole cube cross multiplication equal t square gm. Now r plus h whole cube, equal t square gm divided by 4 pi square. Now cubing root from both sides this equation, we get r plus h equal root cube t square gm by 4 pi square. Now we get r plus h equal t square gm divided by 4 pi square root cube. Now h equal root cube t square gm divided by 4 pi square minus r. So this is the formula of height from the earth's surface of artificial satellite. By using this formula we calculate the height of the artificial satellite. Now we solve a creative question on this topic. Now what is a geostationary satellite? Geostationary satellite means if the time period of the satellite is 24 hours, that means if the time period of artificial satellite is equal to the time period of earth, then it is called geostationary satellite. If the time period of any satellite is 24 hours, then it is called geostationary satellite. So geostationary satellite means the time period of this satellite is 24 hours. Now we solve a creative question, Borishal Board 2019. Here the question is, an artificial satellite is placed at a height of 600 km from the surface of the earth. The radius of the earth is 6400 km. The gravitational acceleration at the surface of the earth is 9.8 meter per second square. Question C, calculate the gravitational acceleration at the height of the stem. So at a certain height, the gravitational acceleration is g capital M divided by r plus h whole square. By using this formula, here M is the mass of the earth, r will be the radius of the earth, and h is the height. Height is 600 kilometer. 600 kilometer, then it is converted into meter. By using this formula, we calculate the gravitational acceleration at a certain height from the earth's surface. And question D is, can it possible to convert the satellite of the stem to geostationary satellite? If it is converted to geostationary satellite, then the time period of this satellite is 24 hours. So time period T equal 24 hours, then it is converted into second. So at which height we placed the satellite, at which height, then the time period of this satellite will be 24 hours. At this height we placed the artificial satellite, then it is converted to geostationary satellite. So we will calculate the height. H is root cube gm. Formula is h equal to root cube t square gm divided by 4 pi square minus r. Root cube t square gm divided by 4 pi square minus r. By using this formula, we calculate the height. What height? If we place the artificial satellite, then it is converted to geostationary satellite. So we write this formula again. Th equal root cube t square gm divided by 4 pi square minus r. By using this formula, we calculate the height. What height? If we placed the artificial satellite, then it is converted to geostationary satellite by using this formula. So thanks to everyone.